We into A cross W. If you remember 2A cross W, we need also another condition here. Redirect bar and address stop. If you remember, okay. So in this case, microprocessor will generate and address this. This data will come on which lines?
Data.
This will come on the address line on A.
Yes.
This will come on
W.
W. Read-write bar will be 1. Chip select will be 1. Address stop will be 1. This data will be read from memory, and then it will be stored in which register? RC. It will be stored in which RC. Is it a data transfer instruction or data transformation instruction?
Data transfer.
Data transfer. From where to where? From memory to
register.
Okay. Quick problem. Okay. Now this is one example. Now we have another example. Move
सर ये एब्सोल्यूट एड्रेसिंग मोड ये ऐड के इंस्ट्रक्शन से आप समझा सकते हैं?
किसके?
ऐड इंस्ट्रक्शन, ऐड R3 R2 जिस तरह आपने यहाँ पे किया
कर लेंगे, क्या इशू, क्या फर्क पड़ता है?
तो उसमें
चल कर लेते हैं, कोई इशू नहीं कर लेंगे। चल ऐड R31 R2 $, $FFFFFC. This is an address. Okay. Now what are the old contents of R31 111111? What are the contents of R2? 0000002. What are the contents of this memory location? 0000006. What are the new contents? 0000008. Where it will be written?
31.
R31. What are the new old contents? What are the new contents?
ये एड्रेसिंग मोड कौन सा है सर?
This is register addressing mode. This is register addressing mode. This one is absolute. Now,
अच्छा, एक इंस्ट्रक्शन में मल्टीपल एड्रेसिंग मोड हो सकते हैं?
yes, that's the question. Now if you see A, now C is equal to A plus B, C may lie within memory or register determined by addressing mode. A may lie within the register or memory determined by addressing mode. B may lie within the memory or register depending on addressing mode.
ठीक है सर.
Clear?
Clear हो
So the addressing modes are not known to the programmer.
Now, what kind of programmer? It's a very good question, but what kind of programmer?
High level programmer.
Addressing modes are not known to the high level programmer, but addressing modes are known to the assembly programmer. Depending on. Now, if you look at the levels of abstraction, so the level of abstraction are different for different people. Okay, from the compiler perspective, so actually there will be different parameters. The register liveliness and things, a lot of things will be there. So actually, if you are talking for abstraction, so levels of abstraction is different for different people. So for a very high level programmer, addressing modes are not known. But for assembly level program, he needs to know addressing modes. And actually also for the compilers. Okay, now, and there are also two types of compilation. One compilation is architecture independent. Other type of compilation is architecture dependent. So these are two different types of. If you are doing architecture independent compilation, so in that case you don't need to know. But architecture dependent, you need to know. You need to know that instruction set architecture of a particular processor. Like in some processor, maybe the destination is on the left hand side. In some processor, destination is on the right hand side. So it varies from architecture to architecture. Now let's assume if you look at cars, for cars, and car has some steering. In Europe, the steering is on the left hand side, and in Pakistan, the car steering is on the right hand side. So actually, it depends on the company which are producing cars. Okay, now we have studied two types of addressing modes: absolute addressing mode and register addressing mode. Now, immediate addressing mode. अब बार देखो कोई आ रहा है?
नहीं सर, मैं बाहर नहीं देख रहा हूँ.
Okay, immediate addressing mode. Immediate addressing mode. In immediate addressing mode, operand is a part of instruction. Operand is a part of instruction. When operand is a part of instruction, so I will give you a very simple example. So let us say add R5, R3, hash 6. Operand is a part of instruction denoted by symbol hash. So whenever you use hash, it means it's immediate. In our architecture, maybe in different architecture they are different. So it means now what we are doing, which addressing mode is this?
Register.
Register. Which this one?
Register.
Which this one?
Immediate.
Immediate. So if you see what are the contents of R3? New contents 0 0 0 0 0 8. These are the contents of R3. And R3 will be added with 6. 8 plus 4 14. In hexadecimal it is E. So actually if you deal with new contents it will be 0 0 0 0 0. So these are the new contents. So in this case immediate is just like constant value. Constant. So if you have C language, in C language, if you say integer C is equal to 5,
This is immediate.
so we can also use it. Let's say if this C is stored in register R3, so we can say move R3 hash 5. If you have this code integer C is equal to B plus 31, how it will be translated? Move. Let's assume this is R9, maybe this is R10. So move, not add. R9, R10.
Nice. 31.
Okay. So immediate value is typically used to initialize a constant value, or it is used to use some constant value. Perform an operation on a constant value. Constant value is some variables. So in that type of operation, immediate. Okay, now can anybody let me know if you do it like this? If you say if you move hash 9 is equal to R3, what will be the output? Lal said
Hash 9 to R3.
9 में R3 should be an error
why should be an error?
because destination shouldn't be a constant
value.
Destination should be a register value.
It can be register, it can be memory.
Memory location.
It can also be memory location. It can also be like this. Add $5632 R3 and R2. So it means we are edit the contents of R2 and R3 and storing
memory
this in
location meant.
memory.
But it's a constant value for 9.
Constant.
So you cannot, yes. Like if you write this in C, it will give you an error. Integer like 5 is equal to C. It will give you an error. And I will also give you a very good example of this. Can you do it like this? Add R3, add hash 9. Just an example. R5 and R2. Let's assume the value of R2 is 6. The value of R5 is 10. So what will be the result? 16? This is also like, it's not like, so immediate cannot be like a destination for this reason.
सर हम स्टार्ट में इनिशियलाइज करेंगे कांस्टेंट को जैसे हमने इंटीजर c is equal to 5 किया तो फिर इंस्ट्रक्शन के अंदर हम c को कॉल करें
C को कॉल करें
मतलब
C को इनिशियलाइज करें
c को हमने इनिशियलाइज कर लिया ठीक है सर और जो मूव r3 किया है उसके साथ हैश 5 की जगह पे हम c लिख लें तो ये सर कौन सी
C की क्या ठीक है आप एड्रेसिंग मोड की बात कर रहे हैं जैसे हम देखिए यहाँ पे हमारी असम्पशन है असम्पशन ये है कि हमने C को R3 असाइन कर दिया अच्छा देखिए अब यहाँ पे मैं एक और बात करूँ which addressing mode should be used it is definitely depending on the compiler needs to decide that whether it should allocate a memory location for a variable or it should allocate a register for a variable it is the job of the compiler. If you are an assembly programmer, you should know that whether you should use a register or a memory location. Now I will give you an example. Let's assume if you have an array of 1000 elements, an array of 1000 elements. So where should you allocate it?
In the memory.
Why memory? Because of limited registers.
Yes.
Okay. Now if we want to have, let's say, if we have a for loop for I is equal to 0, I smaller than 1000 and I plus plus. This I is a loop variable. I is a loop variable. It's a single variable or many variables? Single variable. How many times it is accessed? 1000 times. So where should be it?
Register.
Why register?
Near to processor.
Near to processor and fast. आप समझ आई बात? आपके सवाल का जवाब मिल गया? Good. ठीक है. Okay, direct and absolute addressing mode. Now आगे चलते हैं. बहुत स्लो जा रहा है. मैं ख्याल से थोड़ा सा पास करूँ. We have now we have only until and until now we have only studied that now there are some data registers in the microprocessor. Now we also envision a microprocessor that there are also some address registers. Okay, so we have in the microprocessor we have some data register and we have some address register. So maybe in this microprocessor we have address register A0 to A15. How many address registers are there?
16.
16 address registers. Okay. And what is an address register? Address register will be pointing to an address in memory. An address register is used whenever we want to perform any operation on the data. So now in this context, we have some addressing mode, and that addressing mode is called as register indirect addressing mode. Register indirect addressing mode. In register indirect addressing mode, operand lies in memory. When it lies in memory, so we need an address. So what address of the operand is stored in address register. Okay, now in some architectures, they have separate address register and separate data register. But in some architecture, the register can also be used as an address register, or it can be used as a data register. So there are different mixes. A mixes can be there. It varies from architecture to architecture. But now, what architecture we are assuming? In our architecture,
They are different.
we have separate address register and separate data register. Okay. Now, so if we say this, so how do we? It is denoted by this bracket AJ and with small curly brackets. Okay. So what is J? So 0 is smaller or equal to J is smaller or equal to what?
15, 16.
Number of address
Registers.
in this architecture we have 16 address registers. Okay, so now if we say like this, so now if we say move R3 and A0, so A0 is 0x 000 004. Okay, move not R3, not let's do R6. Let's say the old contents of R6 is 0000111. Okay, okay. So move R3 R6 and then A0. So in this case, A0 is an address register which is pointing to a memory location. This memory location with address 00, and its contents will be moved to which register? R6. What are the old contents? 000. What will be the new contents? What will be the new contents? G. 0x000001 2. So the previous contents was 1 1 and the new contents are 1 0. So it means where the operand is lying? Operand is lying in memory, which is pointed out by an address register A0. So A0 is pointing to this memory location. Its contents will be moved to register R6. Which is this addressing mode? Which is this addressing mode? Okay. Now we have two variants of register addressing modes. That addressing mode is called as register indirect with pre-decrement, with register indirect with post-increment, register indirect with displacement. So we have three variants of register indirect: normal, and it is normal. This one is normal. Register indirect with pre-decrement, register indirect with post-increment, and register indirect with displacement. Okay?
So 4
Normal is like this with pre-decrement, post-increment, and okay. Now I think I need to rub something off from here. Okay, so I'm rubbing something off.
इसमें से ये जो रजिस्टर इनडायरेक्ट मोड है ये हम इन केस ऑफ पॉइंटर ये इतना यूज करते हैं.
Yes. It is typically used to initialize some pointer. It's also used to access some data from an array. Especially if you have an array and now in an array you have a base address and then you have an offset. In that context, I will study. We will study this in more detail. Now in more detail, we'll describe in more detail. Okay. Now for this addressing mode, I need some view of the memory. Okay. So we need some view of the memory and a little bit simple view of the memory. We have a memory. So this memory is, let's assume 0x0000. Okay. I'm using small address bits. Small address just for simplicity. 0x0004, 0x0008, 0x000C, and so forth. 0x1124, 0x1128, 0x1132, 0x1138, then 2C, then 30, 0x1134, 0x1138, and so forth, so on. Now these are the what is this? Addresses. What are this?
Locations.
The content. This is the address of the memory. These are the contents of the memory. Now if we say that we are using now we are using 0x1138. After 38, what will be there? 3C, because we have an increment of 4. So it is byte addressable memory. So it means we can store 1 byte. It is byte 0, byte 1, byte 2, and
Byte 3.
Total bytes are 4 bytes. So it is byte addressable memory. We can access each individual byte. So actually, if you say this is our byte, let's say we have 4 bytes. What is W here? 32 bits. So let's say it is 5A329100. It's the least significant byte and it is the most significant byte. Its address is 0, its address is 1, its address is 2, and its address is 3. Okay, so it's very simple. And let's assume we have 4 seats. Okay, so this address is 0, this address is 4. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So on. Okay, but if you are taking an absolute address, it is 0, then 4, then 8, then C. C is actually equal to 12. Okay, now let's assume we have an address register of AI, any AI. A is pointing to this location. So now we can have an AI, any register. Let's assume this register is A4. and A4 is initially pointing to this location. So what will be the contents of A4? 0x 1 1 2 4. Okay. Now first we will study in this context. In this context we will study then this is 1 1 0 0 0 x 1 1 2 0. Okay. Now we will study register indirect. Here is the cluster with pre-decrement. Register indirect with pre-decrement. So register indirect with pre-decrement. Okay. Where the operand lies?
In the memory.
Memory. Okay. But there is a little bit when we say pre-decrement. So now we will have some register AI and pre. So decrement will be post or pre, before or after? Before. Minus. Pre. When we say pre, so actually if you remember in C or C++, this is plus plus I and I plus plus. Remember? What is this?
Prefix and
Prefix and post. So this pre, this is post. अब आपने लूप का जॉब अगर आपने लूप का देखे I++ और ++ I++ आपने C++ में स्टडी किया. I'm not going in that detail. Okay, so in this register indirect is operand lie in memory. So operand कहाँ पे lie कर रहा है? Lie in memory. So in this case we are interested in an effective address. We are interested in effective address. So what is an effective address? So okay, now if we say move R3 A4 minus, which addressing mode is this? Which addressing mode is this? This one is register. This one is
indirectly
with pre-decrement. Why? Because this is pre and decrement. Okay. So now what will happen? First, in this case, the content A4 will be decremented. First A4 will be decremented. A4 minus 4. First A4 will be decremented. So now, when you execute this instruction, first A4 will, what will you now do the new context of A4? 0x1120. It will point to the previous location. First A4 will be decremented. Why? It is not -4. It is actually the size of the memory.
Memory location.
And actually it also not only depend. It's also depend upon the size of the object. The size of the object. Now if we say an object, so object can be of type character. It can be of type integer. It can be of type float. It can be of type double. It can be of type long. Each data type has different size. So if we say, so it is the size of the object. So if we say, now let's do, if we are using C, C++ or from a compiler. So if we define character, so character is of 1 byte. So this decrement will be actually A4 minus what? Minus 1. If we have an integer, 4 bytes. If we have double or long double, 8 bytes. So it depends on the size of the data type that we are using. Okay? Now this thing is actually relevant to the size of the. So actually all of this stuff is done by the compiler actually, and it is actually hidden from the header. Okay. Now in this particular scenario, what we are assuming, what is the size? 4 bytes. So in this particular scenario, the object that we are accessing is now of 4 bytes. So first A4 will be incremented, and now A4 will be pointing to this location. Okay, and now we have register R3. Now the new contents is, so let's assume this contents is 0x939210AB. These are the contents. These are the 32 bytes. So actually, what will happen? this contents will be moved to which memory?
R3.
R3. What is the new contents? 0x what?
9
9 So this type of addressing mode is called as register indirect with pre-decrement. In register indirect with pre-decrement, first the address register indicated by AI is decremented. Then, so what is the effective address? Effective address is not this one. Effective address is actually the previous one. Okay. Now register indirect with post increment. How then post increment will be accessed? AJ post increment. AJ where will be plus? Here or here? So in this case, okay. Now A4 is equal to A4 minus thing, and then which the memory that will be accessed. The memory will be accessed. The memory. And the contents of the memory at location of A4. नहीं समझे? M is actually the content. Okay, now if you say, now if you look at this memory, now 0x 2 3 9 4 1 2 0x 2 3 4 1 0x A B C 1 0x 0 0 2 6. Let's see, these are the contents. So if you say memory, the contents of the memory at an address $1130. What will be the contents? 1130 0x 0026. So it means this bracket means content of the memory at an address 1130. Now if you say that now this is the address A4, it will be modified minus 4, and then the new address will be memory, contents of the memory, and it is the contents of the register A4. What is the contents of register A4? The new contents $1120, because first A4 is modified. This is step 1. This is step 2. But in register post increment, first the memory location is accessed, and then it is decremented. So now let's see. If we have another register A5, and let's assume A5 is pointing to 112C. So A5 is pointing to 112C. So in this case, if we say move R9, let's assume the old contents of R, we have used R9. Listen, the old contents of R9 is 0000012. Old contents of R9 is 0012. This one too. Move R9, and we say A5 plus. So A5 is pointing to which location? This location. This contains ABC1. What will be the new contents? ABC1. So in this case, R9 contents will be updated with the memory contents of memory, and then within address register of A5, and after the contents of A5 will be changed. And what will be the new contents? A5 plus 1. So what will be the new contents?
002.
So the new contents will be 0x1130. So actually it will be pointing to the next location. So now now we have studied two types of register addressing mode: pre-decrement and post. When they should be used is a question. When should be the answer?
Array.
Yes, array. Then array what?
Offset.
No, not offset. No. Array. When we want to access the data within array serially. Consecutively. Now let's, if you are saying this, let's assume if you have some elements of the array, and we want to find the sum of all elements of the array. So first you need to access the first element, then incremented in next element. So now it's up to you. If you want to move from top to bottom, which addressing mode will you use?
Increment, post increment.
This is indirect post increment. If you are moving from bottom to top,
Increment, pre-decrement.
That's the philosophy. So simple. So that's the reason that if you want to access the elements of the array, okay, now if you want to access the element of the array, if you look at an array, if you have some array in C, how do you initialize it? And can anybody help me in what? Array.
Bracket size
100. यही होगा ना? So it means what is array? Array is actually the address of the first element of array. So actually, if you have an array, so what you do? If you have an array, now what the compiler will do? The compiler will allocate 100 location in memory. The compiler will allocate 100 location in memory. So it is element 0, element 1, element 2, up to element 99. And the first element it will be point to an address register A0. Which function will be used? Actually, now it is the static allocation. It is a static allocation. Okay, so static allocation is actually to the first element will be pointing some address register, maybe some address register A0. And what is A0? A0 is actually array. A0 is actually address of array 0. And what is the address of array 0? The address of the first element of the array. So now let's say this address is, let's assume 0x2000. What is next to 0x2004, 0x2008, and so forth. So actually, if you want to access the first element, actually you have for loop for I is equal to 0, I smaller than 99, and I plus plus. And let's assume you want to have some variable, some plus, and plus is equal to